In this video, we'll be looking at the derivative of arcsine, or any arc trig function for that matter. As you'll notice, arcsine is just another way of rewriting sine as sine inverse of theta. So this right here is the function that is, again, going to undo everything that the sine function does. So if we're looking at this and we're attempting to take the derivative of it, and I'm going to go ahead and use arcsine because I don't want to confuse myself with that -1 superscript that looks like a power that is not a power. Again, that is simply the inverse notation. So using this is more appropriate, I think, for us to look at it. Now, if I know that y equals arcsine of theta, meaning y equals sine inverse of theta, then I can go ahead and apply the sine function to both sides of this equation. Now, again, this is an algebraic rule that we're going to start off with, allowing us to manipulate the function before we take the derivative. So sine of arcsine, because those two functions are inverses of each other, they will cancel themselves out, and I will get theta is equal to sine of y. Now, in this particular case, it might be easier for us to look at this theta as being an x value. So all the way through here, I'm simply going to go ahead and put an x through all my theta measures and change theta to the variable of x. So now I have x equals to the sine of y. And the reason why we manipulated it in this way is because I don't know what the derivative of arcsine is, but I do know what the derivative of sine of y is. So if I go ahead and at this point apply d dx to both sides of this equation, we will first go ahead and take the derivative of x. The derivative of x is 1. On this side over here, the derivative of sine of anything is going to be cosine of that anything times the derivative of the inside, so dy dx. So now at this point, we're going to go ahead and get dy dx all by itself. But if I do so, I'm going to go ahead and divide by cosine of y, giving me dy dx equals to 1 over the cosine of y, which is the same thing as secant of y. Now there's a problem with this, however. If you recall, we don't want to have an answer of our derivative in respect to the variable that our function was in. We want it to be respect to the variable we're taking the derivative in. So that means we need to change this function right here to be back in terms of x. So for me to do that, I'm going to come back up here and look at this notation first. You'll notice that x is equal to the sine of y. Again, that backtracks to this one up here where, the original one, where my sine of any angle equals to x over 1. This implies then that we have a right triangle where my angle is y. Again, this is the angle. It's inside the trig function. If it's inside the arc trig function, that's a side length, or a ratio. So sine is opposite over hypotenuse. And utilizing these two pieces with a right triangle, I can go ahead and say x squared plus my unknown value right here, which I'll call I'll call b, squared equals to 1 squared. Solving for b gives me plus or minus the square root of 1 minus x squared. But you'll notice here, because this is supposed to be a length, we can argue that this is supposed to be a positive case, so 1 minus x squared. If that's the case, I can go ahead and find out what secant of y is, because I now have all of my sides of my triangle. So if I'm looking for the secant, remember, is the flip of cosine, and cosine is adjacent over hypotenuse. So it's going to be this value divided by 1, but because, again, that's the cosine, we're going to flip that to get the secant, so it's going to be that function 1 over that radical. So this ends up being equal to 1 over the square root of 1 minus x squared. And again, the secant of y is equal to this because that's the triangle that is built from knowing sine of y equals to x. So in this case, dy dx, given that y is the arcsine function, is 1 over the square root of 1 minus x squared. All other arc trig functions, for instance, if I had arc cosine of x, then this can be done the exact same way. First step, again, I solve for x equals, getting cosine of y. I take the derivative. After taking the derivative, I will end up with a trig function in terms of y as my dy dx, which we don't want. Then from here, build yourself a triangle. Given that y is inside the cosine function, that's my angle. Cosine is going to be adjacent over hypotenuse, so that's x over 1. And then I can go ahead and solve for the missing piece using the Pythagorean identity, giving me this. Once you know what the derivative of this function is, okay, in terms of dy dx equals to something in terms of y, then we can use this triangle to build the remaining pieces.